Hello, welcome again. We are solving some questions of heat transfer. The topic is one dimensional heat conduction. Question number 36 is a cylindrical tank has diameter of 1.2 meter and a length of 6 meter, has hemispherical length as shown in figure. It carries a gas at 182 degrees Celsius. The tank is insulated with an insulating material of maximum thickness 7.5 centimeter. The room temperature outside the insulation is minus 20 degrees Celsius. If the heat loss is 823.33 watt, then neglecting the resistance of tank, the thermal conductivity of insulating material is option A 0.0078 watt per meter per degree, option B 0.0015 watt per meter per degree, option C 0.0085 watt per meter per degree, option D 0.0065 watt per meter per degree. So that 7.5 centimeter is the insulation and R1 is your zero point 0.6 meter and R2 is your 0.675. Okay. So now we have to determine the heat loss. So uh, the length is 6 meter and so cylindrical portion is having length 6 into, because radius is 0.6, so cylindrical portion will have the length as 4.8 meters. Okay. So now for the cylindrical portion the heat transfer is given by from a 2 pi k L T1 minus T2 divided by log E R E R2 by R1. So R2 is your 0.675 and R1 is your 0.6 and L is your 4.8 and K is conductivity of the insulation, and similarly for the spherical portion the heat transfer is given by 4 pi k R1 R2 T1 minus T2 divided by R2 minus R1. Okay, so summation of these two gives the heat. Okay, so that is 2 so we can take a 2 pi T1 minus T2 as common, and so here add K also as common, because conductivity is, because there is same metal on the spherical and the cylindrical portion, so conductivity is same. So it will be L by log E R2 by R1 plus 2 pi R1 R2 divided by R2 minus R1. Okay, we have taken 2 pi common, so here will be so here will be only 2. Conclusion are according to that. Okay, from this this pi is not there. Okay. And from this we have this, and now we can put the values. L is 4.8 and R2 is your 0.675 and this is 0.6. This is 0.675 and putting the values we can find out conductivity K, because this is your 182 and this is 20. So conductivity comes out as 0.0078 watt per meter per degree. Okay. Next, option A is the right answer. Next, a spherical tank carries a gas at 182 next question 37 and 38 has common statement. A spherical tank carries a gas at 182 degrees Celsius. The tank is insulated with an insulating material of thermal conductivity 75 watt per meter per degree. The ambient temperature and convective heat transfer coefficient is 27 and 150 watt per meter square per degree Kelvin. If the radius of the tank is question 31. If the radius of the tank is 1 meter, then the addition of insulation will option A increase heat loss, option B decrease heat loss, option C may increase or decrease heat loss, option D depends upon the other factor. Question number 38. If the radius of tank is 0.5 meter, then addition of this insulation will increase heat loss, decrease heat loss, may increase or decrease heat loss, depends upon the other factor. So to find out the whether heat will be lost or heat loss will be maximum or minimum, it depends upon the critical radius of the insulation, and critical radius of the sphere is uh, in spherical coordinate is 2k by h. K is conductivity of insulation and h is conductive heat transfer coefficient, and k is given as 75 and this h is given as 150, so it is 1 meter. So critical radius is 1 meter. So when the radius of the tank is 1 meter, then the addition of insulation will decrease the heat loss. Okay, the addition of insulation will decrease the heat loss as the heat loss is maximum at critical radius. Okay, because the critical radius has come out as 1 meter, and at 1 meter the heat loss is maximum. So after that, if we add insulation, then it will decrease it. So the answer to question number 37 is D. So when the tank is when the radius of tank is 0.5 meter, the addition of insulation will increase heat loss up to critical radius, that is up to that 1 meter. So answer to question number 38 is A. Okay. So answer to question number 37 is decreased heat loss, and answer to question 38 is increased heat loss. Next, question 39. A pipe of 25 mm outer diameter carries steel. The heat transfer coefficient between cylinder and surrounding is 5 watt per meter square per degree Kelvin. It is proposed to reduce the heat loss from the pipe by adding insulation having thermal conductivity of 0.05 watt per meter per degree Kelvin. Which one of the following statement is true? Option A, the outer radius of the pipe is equal to critical radius. Option B, outer radius of the pipe is less than the critical radius. Option C, adding insulation will reduce heat loss. Option D, adding insulation will increase heat loss. So here the H is 5 and thermal conductivity insulation is 0.025. So critical radius, we can calculate the critical radius will be 0.05 by 5, that is 0.01 meter or 10 mm. So outer radius of pipe is 12.5 mm. Okay, and so outer radius of the pipe is more than critical radius. So adding insulation will reduce heat loss. So adding insulation will reduce heat loss. So answer is C.